Hi guys, I'm going to read to you Activity 50, the chemistry of acids and bases. There's a lot going on in this activity and I just thought it might make things a little easier for you, and it also will allow you to be able to go back and reread it or re-listen to it again because, as I said, there's an awful lot that's trying to be explained in this activity. So follow along with my mouse. In the last activity, a model for acid and base neutralization, you learned that an acid and a base balance or neutralize each other to form a neutral solution when the number of acid particles and base particles are equal. In this activity, you will explore the chemical reaction that takes place when you mix an acid and a base. First, your teacher, me, Mr. Burton, Mrs. Staniszewski, or Mrs. Wartzenloft will conduct a demonstration. We've probably already done that. Then you will read about how scientists explain the chemistry of acids, bases, and neutralization. So as you know, the challenge here is what chemical reaction takes place when you neutralize an acid or a base. Let me scroll to the next page. So these are the materials you're going to be using. And we know that we've already watched that demonstration that one of us has done. You're going to be using your student sheet 50.2 to guide you through the reading. Hopefully this will help too. I'm not going to follow along with the mouse here because I need to really listen to myself and not mouse along as I go. Two kinds of chemical bonds, ionic and covalent. Again, those are ionic and covalent. All atoms are neutral. They contain enough negatively charged electrons to balance the positive charges in the nucleus. In Activity 36, that was a long time ago, making water and alcohol molecules, you connected the model atoms with white tubes that represented chemical bonds. To understand these bonds, it helps to think of the atom as a positively charged nucleus surrounded by negatively charged electrons. That's exactly what this is shown right here. Here's that positively charged nucleus and the negatively charged electron. Scroll to the next page. You probably know that opposite charges attract and like charges repel. Sometimes the positively charged nucleus attracts electrons from another atom. When the positively charged nuclei of two atoms attract negatively charged electrons from both atoms, they form a bond. Water, alcohol, and table sugar are examples of compounds that are held together by covalent bonds. In covalent bonds, atoms share electrons. The diagram below illustrates a covalent bond. Covalent bonds hold atoms together to form molecules. Here's a diagram that they were talking about. You can see the positively charged nucleus of each of these atoms. You can see that each of these atoms has a negatively charged electron. They share that electron. Because they share that electron, they are called a covalent bond. Then I'm going to scroll down to the next section of this page. In other compounds, the atoms are held together by another type of bond called ionic bond. Ionic bonds form when electrons are transferred from one atom to another, as shown below. The atom that loses one or more electrons is now positively charged and is called a positive ion. The atom that gains one or more electrons is now negatively charged and is called a negative ion. An ion is an atom or a group of atoms that has gained or lost one or more electrons and is now either positively or negatively charged. The positively charged ion and negatively charged ion attract each other and form a bond, but they don't form a molecule. A compound that forms as a result of ionic bonding is called an ionic compound. Table salt, NaCl, or sodium chloride, is an example of an ionic compound. Now remember, you can push the pause button anytime you want to get these notes down in your notebook. Scrolling down to the next page. Here is an example, or what they were talking about on the previous page, of the ionic bond. You can see positive charge in the nucleus, positive charge in the nucleus, negative charge of the electron. Now you can see that this electron is jumping over here. Now these two things are joined together in an ionic compound. It is a negatively charged ionic compound because there are two negatives over here on this ion. Well, let's look at the next section. Dissolving covalent and ionic compounds. When you dissolve some substances in water, the substance separates into molecules. For example, when you dissolve sugar in water, individual sugar molecules mix in among the water molecules. You can see here's the sugar. It's dissolved. We now have water molecules and sugar molecules. However, when other substances such as acids and bases and salts are added to water, they release positive and negative ions that mix completely with the water. That's not the case here. Sorry, I should have continued on the next page. They mix completely with the water molecules. For example, when table salt dissolves in water, it separates into separate positive sodium and negative chlorine ions, as shown in the diagram below. So here you have your salt. It's NaCl. That's where they get these two sets of, or these symbols from. And it dissolves, and you can see here we have the whole water molecule, but the chlorine from NaCl and the sodium from NaCl have separated. When hydrogen chloride, HCl, a covalent molecule, dissolves in water, it releases positive hydrogen atoms and negative chlorine ions. Sorry, I said that wrong. Positive hydrogen ions and negative chlorine ions. Any substance that increases the concentration of positive hydrogen ions when it dissolves in water is an acid. That sentence is important. When a KOH, that's potassium hydroxide, you've used that before. When a potassium hydroxide molecule dissolves in water, it releases positive potassium ions and negative hydrogen oxide ions. Any substance that increases the concentration of negative hydrogen oxide ions when it dissolves in water is a base. Another important sentence. You have observed that substances that separate into ions when they dissolve conduct electricity. These substances are called electrolytes. Scroll down to the rest of this page. Reacting acids and bases. In Activity 49, Modeling Acid-Base Neutralization, you use models to explain the neutralization of an acid with a base. Another way to represent the neutralization process is with a chemical equation. A chemical equation is another kind of model for a chemical reaction. One way to write the equation for the reaction of a hydrochloric acid, HCl, and the base potassium hydroxide, KOH, is in a word equation. Hydrochloric acid plus potassium hydroxide will yield potassium chloride plus water. In reality, that should be written in one line. Instead of, because the page was skinny, they had to put that down into a second line. Another way to write the equation is to use the chemical formulas for each compound in the reaction. You can see they've done that here. HCl, hydrochloric acid, plus KOH, potassium chloride, will yield KCl, that's potassium chloride, plus H2O, that's water. Potassium chloride, like sodium chloride, is classified in a group of chemicals called salts. A salt is an ionic compound that contains positive and negative ions. The general equation of an acid with a base is, we take this acid plus a base, and we get a salt and water, just like there was up here. Now it's just as they're saying the general equation. This can be simplified to show only the neutralization of the acid and base as positive hydrogen ions plus negative hydrogen and oxygen ions will yield H2O. You can see H here, or 2 hydrogen ions, 2 hydrogens here, one positive, one negative, one oxygen, and another oxygen from here. Let me scroll to the next page. This equation explains why the product of this reaction is neutral. The numbers of positive hydrogen ions and negative hydrogen oxygen ions are equal, and they react to form water. It also explains why the product of this reaction conducts electricity. The other product of the reaction is a salt with the formula KCl, which is potassium chloride. When a salt dissolves, it separates into I'm going to read that sentence again. When a salt dissolves, it separates into charged ions that can conduct electricity. If you let the water evaporate from the solution, crystals of potassium chloride will form. You may be surprised to learn that table salt is only one of many compounds classified as salts. Most of the salt in the ocean is sodium chloride, but some of it is potassium chloride and other salts. Potassium chloride is the substitute for table salt that people on low sodium diets often use. Thanks for listening. I hope this helped. Remember, you can go back and listen to this as many times as you need to. Pause it as often as you need to make sure that you get the information down in your notes and that you understand it too. I'm sure that you'll talk about it a lot more with your teacher, but this was a good place to start. Have a good day. Bye.